tool. We opened up the intake port on these 911 heads for a class race car. Made a quick fixture for just a little bit. I think it's 36 millimeter. Not a big dude. Little guy stock. Fun. Jack scanned them with the little peel scanner, and I modeled it all in SolidWorks. Took me a little bit to get the file converted so I could use it as my stock. Works pretty slick. The runtime there was about 3 minutes. I cut out the boring part just so we could see it fly around. So we're using this Peel 3D scanner, uses structured light, and it generates this triangle mesh that we can stick geometry on for bolt holes to find those studs and the port center location, that kind of thing. So we bring that into the CAD package. The mesh looked like this. We were mainly just worried about this inside of the port, so we didn't spend a lot of time on the rest of it. I did turn this into a watertight mesh so I could use it for my machining simulation. I had to scale it 25.4 times because it kept bringing it in as inches and millimeter. So my fixture, I did actually draw in SolidWorks the bolt heads, offset my port a little bit so it didn't rub, and so I could get a nice machining simulation, make sure the tools aren't going to hit. You know, I didn't want to waste any of these heads, even though my one setup part, you might notice, had a cracked valve guide support. The fixture, I just flipped the 5-axis vise around, stuck it here on the side for a little extra clearance, programmed it to A-90 and C90, and then probed the center of the part. So that let my head just basically bolted off the center rotation on the table to give extra clearance. Then it gave me this left-handed loading position, which was a little weird, but all in all it worked. Went together pretty simple. So one's down, then we just run a bunch more. Quite a few of these intakes had the studs bent on them, so they didn't want to go in the fixture. So I used a nut to protect the threads and then tapped them back until they were true, and then they'd work.